Hello friends, this video on equilibrium part 13 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched all the previous parts. Now, if I want to find the direction of reaction, whether the reaction will go on the left hand side or the right hand side, how will I find? Now I have told you the percentage that okay, 80%, 70%, 90% of the reactants will react to form product. But the question is, what is the direction? Whether the reactants, because sometimes, as I told, for example, I have A plus B is equal to C plus D. It's a reaction here. And if I give, let's suppose, X mole of this, Y mole of this, Z mole of this, and P mole of this. Now I'm not sure that if I start with these concentration, whether the reaction will be forward direction, backward direction, I don't know. Because it all depends on the initial concentration, right, of A, B, and C and D. Correct? That is something I don't know. So how to find the direction of the reaction? So this we can do if we know something called reaction quotient. So for this, we have to find something called reaction quotient. And then by comparing this reaction quotient with my K, I can find the direction of the reaction. Okay. So what is reaction quotient? So reaction quotient is similar to my equilibrium constant. For example, equilibrium constant was something which we find at equilibrium, but reaction quotient is nothing but similar thing, but it need not be in equilibrium. It is at any point we want to find. Generally, this is we generally find this as t is equal to 0. Generally, but it is not that you have to find a t is equal to 0. You can find a t is equal to 1 second, 2 seconds in time. But generally, see, when you talk about equilibrium constant, we tell that we have to find what? The concentration of the product to the power stoichiometric coefficient by concentration of reactants to the power stoichiometric coefficient at equilibrium. There we specify that you have to find these values at equilibrium. That means you keep some reactants A, B, and then let it form products. And then after the equilibrium has been reached, you find the concentrations of all these values, and then you find the Kc value, right? That means you're talking about the Kc at equilibrium. You don't calculate this Kc at t is equal to 0, t is equal to 1, t is equal to 2. You don't care. You calculate this value only at t is equal to equilibrium. But if I want to find this value at any point, then that value is not Kc because this is constant. That value is called reaction quotient. And generally it is found at the initial level. For example, I have this reaction. I'll find the reaction quotient here, and then I'll compare with the K. And then I have various formulas here. If my QC is greater than Kc, the reaction will proceed in direction of the reactant, that is reverse reaction. If my QC is less than Kc, it is forward reaction. And if my QC is equal to Kc, that means my equation or the whole system is already in equilibrium. Please note, if QC is greater than Kc, right, it will be in the reverse direction. Logically, if you don't want to remember this, just see this. QC is what? My product's concentration to the power by reactants, right? So if my products are more, see if QC is greater than Kc, right? If this is greater than Kc, and this assuming, that means my products are more. See, this QC can greater than that means that this product is more than what it should happen in equilibrium, right? This is product at any time t. So product at that particular time t, at that particular time, is greater than the product at equilibrium, right? Because Kc is what? Kc is nothing but product at equilibrium, concentration the power stoichiometric coefficient by reactants concentration at equilibrium. So if this is greater, that means product is more, right? QC can be more only when the product concentration is more. If the product concentration is more, obviously some of the product will be used in the backward direction to create some reactants, right? So if I pump in more products here, what will happen? The reaction will shift inside, correct? So if my QC is more, that means my product is more. If my product is more, if you pump in more and more products here, the reaction will move backward direction, that is the reverse direction. If QC is less, that means my product is less and reactants are more. If reactants are more, if you pump in more and more and more reactants here, the reaction will move in the forward direction, and thus the reaction moves in the forward direction. And if QC is equal to KC, that means it is in equilibrium. Very simple. Hope you understand. See, even if you don't need to learn this, just understand the concepts. QC is nothing but my concentrations of the product and reactant at any time t. So if QC is greater than KC, that means my product concentration is more at that particular time if you compare with the product concentration equilibrium. So if the product concentration is more, that means my equilibrium will move in the backward direction to make sure the product is less, right? Same thing, if QC is less than KC, that means my product is less. If my product is less, you produce more product. That you can do by reacting reactants, that means my reaction will be in the forward direction. Correct. We'll take some examples where we'll predict the direction of the equilibrium. So the question says the value of Kc for this reaction where 2A is in equilibrium with B and C. The Kc value is nothing but 2 into 10 to the power minus 3. At a given time, at some time t is equal to t, I'm not sure, or t is equal to capital T, some time, the reaction mixture is, the concentration of the reaction mixture is A, concentration is equal to B is equal to C, and the concentration is 3 into 10 to the power minus 4 mole, molarity, that is 3 into 10 to the power minus 4 moles per liter. So we have to find the direction of the reaction. So Q is what? Q is what? Concentration of B, concentration of C by concentration of A square at time t. So I'll put at time t. Correct? So what is the concentration at time B at time t? Same. What is the concentration of C at time t? Same, 3 into 10 to the power minus 4. What is the concentration of A at time t? 3 into 10 to the power minus the power 2. So you solve this, it comes out to be 1. So my Q is equal to 1 and Kc is what? Kc is 2 into 10 to the power minus 3. So which one is more? Obviously Q is much bigger than Kc. Much bigger than Kc. So if Q is bigger than Kc now, what will happen? The reaction will go in reverse direction. Why? If Q is bigger, that means my products are more. If my products are more, that means Q is bigger, that implies products, more product exist at T is equal to T. If more product exists, the equilibrium will go in the reverse direction. Correct? Easy one. Let's take one more example. A mixture of 1.57 mole of nitrogen, 1.92 mole of hydrogen, 8.13 mole of ammonia is introduced in a 20 liter reaction vehicle. Please note 20 liter is the volume is in liter, so I'll just circle this. At 500 Kelvin, at this temperature, equilibrium constant for this reaction is 1.7 into 10 to the power 2. Is this reaction in equilibrium? Yes or no? See, if reaction is in equilibrium or not, we can tell only, we can find the value of Q. And if QC is equal to Kc, that means my reaction is equilibrium. So let's find the value of Q. So my reaction is N2 plus 3H2 gives 2NH3. So my Q is nothing but concentration of NH3 to the power 2 by concentration of N2, concentration of H2 to the power 3 at T is equal to T. Everything at T is equal to T. Sometime. Or T is equal to 0, you can say. Because we are starting only now. Now, at this time, what is the value of NH3? NH3 was 8.13 mole per 20 liter. Right? So 8.13 by 20 to the power. What is N2 concentration? 1.57 moles per 20 liter. So by 20. What is the H2 concentration? 1.92 moles per 20 liter to the power 3. Correct. So if you solve this, comes out to be 2.38 into 10 to the power. Let's compare this value with Kc. Kc is 1.7 into 10 to the power 2. Are they same? No, they are not same. QC is greater than Kc. correct? If QC is greater than KC, that means my products are more at T is equal to 0. That means if my products are more, the reaction will go in backward direction. I hope you understand. See, I found the value of QC and the QC's value is not equal to KC. That means the reaction is not in equilibrium. Now the next question is which direction it will go. So you see QC was greater than KC. QC is greater than KC. That means the products are more at T is equal to 0. Then what it should be if you compare the value of product at equilibrium. That means reaction will go in the backward direction. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.